So for generators, a number k is a generator of Zn if and only if it is relatively prime to n. And what does that mean? What does all of this English mean? It means that the greatest common divisor between k and n has to just be 1. That means they don't have any other common divisor. And here, like I said, here our n is 12 because we have Z12, Zn, Z12. So how to find the generators is that we're going to find all the k's such that the greatest common divisor between k and 12 is 1. Now we're going to be using all the elements inside here. Now we're going to be testing using each and every element. Testing with 0. 0 a generator of 12. What is the greatest common divisor between 0 and 12? It's not 1, so 0 is not a generator. The greatest common divisor between 12 and 1 is 1, so 1 is a generator. The greatest common divisor between 2 and 12 is 2, so 2 is not a generator. The greatest common divisor between 3 and 12 is what? 3. So 3 is not a generator rather. The greatest common divisor between 4 and 12 is 4. So 4 is not a generator. The greatest common divisor between 5 and 12 is 1. That satisfies. So 5 is also a generator. I'm just going to write 5 here. The greatest common divisor between 6 and 12 is 6. Doesn't satisfy. The greatest common divisor between 7 and 12 is that's 1. So 7 is also a generator. And then the greatest common divisor between 8 and 12 is 4. Yeah, that's 4. And that's not 1. So 8 is not a generator. The greatest common divisor between 9 and 12 is 3, not 1. It's not a generator. The greatest common divisor between 10 and 12, I think that should be 2. So it's not 1. Then the greatest common divisor between 11 and 12 is 1. So 11 is also a generator. Therefore, the generators of Z12 are 1, 5, 7, and 11. And what this generator means is that I can use each of these to generate this thing back by operating it on each other, operating over and over and over and over again. It's going to give me these values. Yeah, and that's it.